Yes, today we'll start with the first topic. So that is water body map. Okay. So initially, what we will do is we'll use the bands that we need for calculating the NDWI. So first NDWI. So let's see the formula for NDWI. Okay. So NDWI formula, if you search in the browser, sorry, NDWI formula. So that is for the line side files. So let's check for the line side. Let me just share the screen first. Is my screen visible? Can anyone confirm? Yes. Okay. So first we are working on water body mapping. So when you're working on water body mapping, so if you want to prioritize water body with the other areas that you have in any of the regions. So first thing that you want to do is calculate the NDWI. Okay, so NDWI is a method where you are giving the inputs as a bands and you are getting an output only for the water body region. Okay. So NDWI formula for the Landsat files, we have the formula band 4, that is for the Landsat 8. So you have the formula band 3 minus band 5 divided by band 3 plus band 2. Okay, so this is the basic formula where you will actually divide the classes for other classes with respect to the water body. If you want to separate water body with other classes, you can actually make use of these bands which are available from the Landsat 8, and you will actually apply the formula to get down. Okay, so this is a basic formula. So remember this formula so that we can make use of it. Okay, so first thing is I have uploaded. So I'm using Collab to work on the codes that we have already written. So the bands here I have is band 3 and band 5. Okay, so that is from the Landsat 9. So again, both the bands 8 and 9 both are the same time. So for that reason, the number of bands is same. So we are using Landsat 9 data and we are using band 3 and band 5. Okay, so along with that, so I have the shape files, the vector data for the Bangalore. Okay, so these are the inputs that I need to work on water body mapping. Okay, so after that, so first thing is if you are working in Collabs, first thing is you have to install the supporting libraries that you need. So here we are installing 4 libraries. So one is Matplotlib. So this is a library where you use this library to create the plots. So that is, you create a map giving x-axis and y-axis. Those things you can actually give by using these libraries, and you create a plot of it. So this is used for this is done by Matplotlib. So then NumPy. So it is a library where you can actually create an array and you can work on the data that you need. So here we are using the raster data. So NumPy is very much important because each of the pixel data that we have in each row, that is in a form of a. So that means NumPy is very much essential when you are working in the raster. So then you have raster. So whatever the processing part, analysis part that you want to do using the Python. So raster is one of the important libraries to work on the raster data. So then GeoPandas is to work on the vector data. So here for Matplotlib, so we are using to create the plots, and then for NumPy work on the NDWI, that formula that just now I said, to work on the calculation part and also to access the data for each pieces. So for that we are using raster. Obviously we are using the raster data to separate things to the bands. So for that reason we need the raster and also for clipping the data to the vector domain. So then you have the GeoPandas to read the vector data that I already found. That is the Bangalore. Okay, so these are the libraries that we need. So basic libraries that we need to work on the water body. Okay, so Just to install it in the collab, so just click exclamation mark, PIP, install, and the library that you need. Just run this. So I've already installed, so it is showing the requirement already set. So you will get all the, if any of the supporting files is not yet installed, so you get the files which needs to be installed. Okay. So all these libraries are already installed. So you don't have to, if you have already installed and installed, just want to show you that so to install the install. Okay, so then even though it is installed, so when you are working on the codes, first you have to import it. So I'm just importing. The first is the import raster, and in the libraries you have multiple things that you have to install it along with. That means from raster.mask, you're importing the mask. So this one is used for clipping the raster to the vector. So one is to work with the raster, and one is to clipping the data to the particular vector boundary that I have. So in GeoPandas is imported to work on the vector data that I have to read the vector data. So then you have Matplotlib create the plots after getting the output. Okay. So now I've done the importing. So then since we have two bands here, so we are creating the for. Okay. So Python for loop, the syntax goes like this: for I in range. Okay, so this range 2 means that it starts from 0, even though I have not mentioned it as 0, and it ends at 2, where 2 is non-universal. So the structure of Python, if you want to know it, so if you just give for I in range, so even though if you give 0 comma 2, and if you give 2, both are same. Okay, so here I've given this 2. So even if you give 0 comma 2, it is fine. So then if you just give print I, so you're getting the output as 0 and 1. Okay, so that means it will consider 0 and 1, but it is non-universal. So the same thing I'm doing it here. So the structure is the same, that is the for loop, and within the for loop I'm reading all the codes that I've written in the for loop. That means the first loop it goes till the end and goes back again, and it will read the second data. So since I have two bands here, so first I've created a list for these two bands, and it will pick up each of the list, each of the item in the list, and then it goes to the code. So then goes back again, it takes up the second data and then runs to the code. Okay, so for that reason, to avoid the repetition of the code, so I've just created for loop and I've created a list for both the bands. Okay, so for I in range 2, that means first I becomes 0. So here I've created raster path. So that is the path of this two raster band. So just click on these three dots and then copy the path. Copy and paste it. Okay. So similarly for the other band also you can paste it. Okay, so I have added band 3 and also band. Just to cross verify this. Okay, so band 3 and band 5. So it is in a form of a list. That means the first item that I have has the index 0 and the second item I have is the index 1. Both of them are saved under the variable raster underscore path. So then you have one more variable shapefile paths. In this I'm just adding the shapefile, that is the band. So just copy this and paste it. Okay, so now we created two variables, one is raster path and one is shapefile. Where raster path has two bands that we require to create the NDWI, and then the shape boundary that we need. So to read the shapefile, so we have GPD. Okay, so what is GPD? So GPD is nothing but GeoPandas. So I'm importing GeoPandas as GPD, and then I'm just reading the file. Okay. So to load a shapefile, so you need a GeoPandas. So we are creating a variable clip shape. In that we are storing the shapefile that we need by reading it using GeoPandas. Okay, so GeoPandas.read file, we are reading the shapefile that we have. Okay, so since we doesn't know what is the projection of that, so that is the geometry, that is shapefile that I have, and also the raster file that I have. So we are opening the raster file. So with raster dot open in this parenthesis, we will mention the raster path. So here I have given it as I, so that since I am using for loop, so in the first loop I have I is equal to 0. That means raster path 0. That means the first data that I have, that is band. So for that band, so I'm using the raster CRS is equal to src.cs. So here I'm opening each of the file and then I'm naming it as src. Okay, so src is just a variable, it's just nothing but a source. So we are using that src as a variable and we are acquiring the CRS command. That means the band 3 that I have. So its CRS is being saved under raster underscore CRS in the first one. Okay, so then whatever the CRS that I have for raster CRS, so we are shifting it to the shape. Okay, so clip.shape is a variable which is reading the shape. Okay, so we are adding the CRS of raster and then we are adding it to the shape. Okay, so making sure that both of the CRS that we have for the vector and the raster both should be same. Okay, so then we are clipping clip shape. It is a CRS and we are applying the geometry. Okay, so now we have reprojected, that is for the CRS we have cross verified and we have applied, we have made sure that raster and the vector have the same CRS. So then we have created the path. So we have pasted the path here. So after that we have to first clip the boundary that we have. So with raster.open, again we are just opening the raster data that I have, that is the band, and naming it as SRC. So here we have two variables, one is clip raster and one is clip transform. Okay, so from the mask output, so we are getting both outputs. Okay, so whenever you are clipping, so the first thing that you are getting is for the bands. Okay, so the bands, okay, so bands, rows and columns. Okay, so these three datas that you are getting, so this will be added in the clip raster. Okay, so this data is very much necessary to be added in different formats. So for that reason we have created two variables where it will be using bands, rows and columns that will be added in clip raster, and then in the clip transform, so you have the location or the georeferencing, so those parts, so including the locational values for each of the pixels and for each of the corners of the raster. So those data that we have with respect to the location, with respect to uh, the geography, so that part is added in clip raster. Okay, so now after that we are using mask. So within the mask we have source and the geometry. Source is nothing but the band and geometry is nothing but the vector data. So it's clip underscore shape dot geometry. So we are just cropping it. We are giving it as crop is equal to true, so that we are cropping whichever the extent, whichever the file has more extent, which will be cropped to the lesser extent. Okay, so we have the more extent. The more extent is the raster file has a more extent. So raster file will be clipped to the geometry area. So then we have done for the raster part. So but the metadata is not yet done. So when you are just changing the raster boundary and the transform, so there might be some changes in the metadata. Okay, so for that reason we have to make sure that the metadata also will be placed into the same file. So for that reason we are just picking up the source file and we are picking up the data, that is the metadata that we have in the source file, and then we are copying it. So the copied metadata is saved under clip. So we have copied the original data, but we have to update the data that we have. So since we have clipped the source file, so we have to update the updated data, correct? So for that reason, in the copied data, so we have to change the required data that which is already being changed when we are clipping. Okay. So we have copied the full metadata. So the metadata that we have in the clipped meta is nothing but the metadata of these bands. Okay. So it is not the metadata of the clipped band. So it is the metadata of these bands. So now we have to update of the data in this data. So now after that we are just updating the data that is in the clip data. So I'm just using update and creating an XT order. Okay. So here we are creating keys and values where driver, height, width and the transfer. So see, these are the keys and these are the updated values that are. Okay, so we have done the clip and also done the transform. So we have to update the meta for this. So we are updating it here. So one is geotiff, so gdiff, and then we have clip raster dot shape one. So shape one is whenever you are reading the data, I have shown you the data that you are getting as an output in the clip raster, correct? So in the clip raster, we are getting lines, rows, and columns. Okay. So here you are using one and two to pick up the data of rows and columns. Okay, so that is when you give dot shape one, so you'll get the number of rows. So if you have number of rows, so you have the height of it. So this is the row. So if you have, okay, so assume that you have a raster here. Okay, so from here, if you have the number of rows, you get the height of the complete raster. Okay, so for that reason, I'm picking up the rows here and I'm adding it for the height. So then you have here you have two. That means you are picking up the number of columns. Then you have the number of columns that you have. So that means you are finding out the width of the raster. So for that reason, I'm using the columns to add it in. Okay, so that transform we have already added it the under the variable get transform. So for that reason, we have created two variables to get out. So that you have to update the meta for the output raster. Okay, so then we have updated the meta. So we have flipped the raster to the particular vector boundary. Then we just have to see with raster.open whatever the raster that I've created, you will open it and then click raster I. Okay, so here we are using star bracket because we are using format to read the particular dynamic data. So here output that will give is clip underscore raster underscore zero dot. And in the next loop, so I becomes one, then you are getting output as clip underscore raster underscore one dot. So we are writing it, so that means we are creating file and then double star, that is double asterisk, and we have clip underscore meta. So why we are using double asterisk? To open the dictionary. So this is a format to open a dictionary and to access the data that we have. For that reason, we have opened the dictionary and we are reading. So this complete opened raster, we are naming it as GST. Then we are writing the GST dot write clip raster. Okay. So this is the first call, the first code where we are actually setting the boundary of the bands to the particular values. So now I just run this. Okay. So the code for the green signal, so we got the two files that I made. Yes, raster 0 and 2. But both the files. Okay. So clipping is done. So now we have to find out the NDWI and also plot the map that we. Okay. So now we have two bands. So one is with raster open, that is NIR band. So here as NIR, and then here in NIR band data we are reading the NIR dot read one. Okay. So as type we are reading the data as, so that means for each of the pixels that we have. So each of the pixels that we have, so we have the font. Okay, so that means for each pixels the data we doesn't have integer, we have the font. So for that reason we are just reading the data that we have. Okay, so then we are calculating NDWI. Just a second. Okay, so here you are calculating the NDWI. So in NDWI the formula is, as we have discussed before, the green data minus NIR and then divided by green data plus NIR. So as we have discussed, band 3 minus band 5 divided by band 3 plus band. Okay. So after that what we are doing is, so we have a function NaN to num. So that means if you have any NaN data in any of the pixels, so then that particular pixel will convert that into 0. So when you have NaN, the automatically this function will convert that to 0. So we are just handling the NaN to any of the values. Okay. So after that, we are creating the subplots. Okay. So subplots is, so when you create a one single image, so in that if you want to add multiple plots, this for the multiple maps, so then you can actually create subplots by using Matplotlib. Okay. So PLT is nothing but the Matplotlib editor. So if you just go to the top, so you have matplotlib.pyplot. So in this I am mentioning that complete library as PLT. Okay. So we are making use of the PLT and creating a subplots by using Matplotlib. So here you have 1 as well as 3. So that means this is the row and this is the column. So when you are creating subplots in a single image, so how many rows you want and how many columns you have to mention that. So for that reason we have given 1 row and 3 columns. In a single row I'm getting 3 columns. So the figure size is 15 inches and 5 inches. Okay. So then you have the thresholds. So when you create NDWI, so you will get the data from -1 to +1, correct? So more than 0, so that is the actual data that you separate the water class in the other class. So for that reason, we are just creating a list that is 0, 0.1 and 0.1. Okay. So we will be creating 3 plots by separating these data, by making use of these data. That is more than 0 and more than 0.1 and more than 0. Okay. So again we are using the for loop where we are creating 2 variables I and thresh. Okay. So that is for each of the data that we have thresholds, we are naming it as thresh, and we are making use of I to read the access. Okay. So then you have variable water mass. So in this we are creating NDWI greater than thresh. So in the first loop the thresh becomes 0.0. So that means whatever the NDWI value that I have, so which is more than 0, so that will be stored as water mass. Okay. So that data will be used here to plot the map. So that is here I'm just using the whatever the data that I have in NDWI more than 0.0. So that will be used here to plot, and in the CMap you have multiple inbuilt colors in the Matplotlib. So in the CMap is one of the variable parameters, so where you can actually give the colors. So here I have given the colors as blues. Okay. So then it is just reading the data and then giving the color. Okay. So then we are just setting the title to water mass. We have threshold greater than threshold. It is this complete string that I've given. So this is a title. So where thresh is a dynamic. That means whatever the loop in the loop, whatever the value that I get from the thresholds, so that will be added here. So in the heading itself, so I'm getting threshold greater than 0.0, or the next loop threshold is greater than 0.1. Again, the next loop will get threshold is greater than 0.1. Okay, so then we are just giving tight layout, that means it will automatically split the spaces that it has equally in the 3 subplots. Okay, so then just giving a show at the end so that it will be getting it down. Okay, so these are created for these thresholds. So we are creating thresholds from 0.0, 0.1 and 0.2, and we are creating 3 subplots. Okay. So then what we are doing is we are just creating a final plot which is more than 0. So that means the complete map that we need to know the complete water body area in a single map. So for that reason we are just creating one more plot. Okay, so we are just opening the the band that we have, the green band, and we are mentioning it as green, and then we are printing the green dot strings. Okay, so that we are just printing out the CRS out of it. So then again we are adding the shapefile and we are printing the CRS, and after that we are assigning the boundary to the green CRS. That means whatever the green band has having CRS, that we are assigned from. It is nothing but again we did the same thing in the previous code. That is nothing but split function. So you're just assigning the projection of green bands, the boundary that. Okay. So then the equation is again the water mass is equal to NDWI greater than 0. So we are creating the final map. So for that reason we are just using only one uh, condition, that is it should be greater than 0. Okay. So then again we are creating subplots where we are creating only one plot. Okay. So that is 15 to 8. So then the title are given as water body mapping the boundary. So we are adding the boundary as well. So till here what we have done, we are just adding the NDW. Okay. So to add a boundary, so again we have to pick up the data that we need for the bounds. That is the boundary data. So for that reason, just opening the green band and then we are picking up the bounds. So what that is for the left side, right, bottom and top. So picking up the bounds and we are saving it under the variable x. Okay. So here we are plotting the NDWI and here we are plotting the boundary. Okay. So here we are plotting the water mass, that is storing the data NDWI greater than 0.0. So then you have the color, and then the extent, and then the origin upper. So origin upper is nothing but the initial point should be in the top left corner. Okay, so the values that we are getting, so it should be starting from top left. Okay, so then this is for the boundary plot. So then here you have face color, there is none because we need just a boundary but not the field color. So for that reason we have given none, and the edge color is red and the line width is 1. Okay, so then you have color bar. So you get a color bar at the edge so that you get to know what is the intensity of water presence in the particular map. So then you have show. Okay, so this is a complete code that we have to create a map. So before that, so here we have created NIR, but we haven't mentioned the location. So we just mention it here. NIR underscore man is equal to, we just give the location. So here, so you'll get this 0 and 1. So here for the NIR bands, you have the created two values. One is 0 to 1. So when I becomes 0, it picks up band. So that means band 3 is green. So and in the second loop, so you'll get band 5. In the band 5 it is NIR. So here 0 is green and 1 is red. So just copy this part for the NIR. So this. So then you have green band is equal to, then you have this 0. Copy this here. Okay, so these are the two file paths. So I'm picking up the clipped file that I have in the content table. So and I'm naming it as NIR band and green. Okay, so NIR band is same. Okay, so it is the same, and then for the green band, yeah, it is the same. Okay, so now let's just run the second loop. We are getting an error data. So here I went, let's check. Okay, so I have opened NIR but I haven't opened the green. So just open the file. So here I'm just opening the green band as green. So this I'll change the value green data. So here I'll just change green. So I've opened both of the files. Which one? NP. Okay, so NP is num. Okay, so I haven't installed num. So just install it. import. Yeah, mistakes. Or you can do it in that file. As NP. So let me just check if I have installed the number. So I've installed it, but I haven't. Yeah. So now after clearing few of the errors, so now we are getting down. Okay, so here we have three maps that we created using the subplots. That is water mass, that is threshold greater than 0, threshold greater than 1, and threshold greater than 2. So based on the data that we got, so we are splitting out the data in three subplots, and then this is the final data that we got. Okay, so in the code, as I've explained, so we created two plots. So one is this one. So using the thresholds, we created the subplots by using the three data 0, 0.0, 0.1 and 0.2. So we got a subplots in a single row in three columns. This is a single row and we have three columns. So after that, we created one more plot where we are adding the NDWI, which is greater than 0.0, and then after that we are just adding a boundary to get the outer boundary. Okay, so here you got the Bangalore boundary, which is in red color, and then the water body in the final. Okay, so this is the final output that we needed to map the boundary for the benefits. So for the people who are present right now, so I'm just giving you a task, so where you can actually, so anyway we have already completed this water mapping, so you can make use of this code so that we have discussed right now. So you can make use of this code and you can find out the regions for your home. So if you complete the code and also if you share the documentation, so we can upload it in our website as a blog. So again, who comes first come first serve. So the one blog we can upload. So if you complete the task for your own region and if you prepare a documentation for the same code, so we can upload the blog that you have created and also we can mention it in this. Okay, so this is the one easy task that I'm giving. So if you want, you can just make use. So that is end from my side.